Hey guys, we're going to do the practice test for 10, and the test is the next class that I'll be there. So depending on if I'm going to be absent next class or if I'm here. So let's do it. We did this part in class, right? We did this part in class. And so let's do this part. So this part helps us read and remember the formulas and the methods, okay? So here it says JK is what we're solving for. Find the length of each arc in terms of pi. So we have it in terms of arc length, but we know the radius. So we know that if the radius is 5, the diameter is 10, so the circumference is 10 pi. So this can't be 10 pi, it's something smaller than that. So it'd be the ratio, 112 over 360 times the circumference, 10 pi. All right. That's basically it. Then the rest of the problem here, I just have to make this look a little bit cleaner. So I could leave my answer, 112 divided by 360 times 10. It looks like I get 31.1 pi. Probably not the best way to leave my answer. So probably a better way is to cancel this and notice that I could have this let's see. I still have these two numbers are even, so I could divide by 2. I'd get 56. Divide by 2 down in the bottom, I'd get 18. Those are still even, so I can divide by 2 on the bottom and the top. I get 9. 56 divided by 2, I get 28. So let's see if that is. So 28 over 9 pi, would that be the same answer? Let's try that decimal. 28 divided by 9. Yep, that's that same decimal. Okay, so if it's multiple choice, it probably will say this. If you got this answer, you could go, oh yeah, that's the same decimal. All right, now they want A, B, C. That's the major arc. So if this is 154, then I want this bigger angle. All right, so I get 206. So 206. So what's that arc? It's 206 divided by 360 times my circumference. So if 8 is my radius, then the diameter is 16 and the circumference is 16 pi. So I want 206 over 360, 16 pi's. So I get 54.93 repeating. It's a little hard to see, so let me just rewrite that. 54.93 repeating pi. Technically, probably not my best answer in the world. It's probably, I should be able to reduce this fraction. So I notice that has a 4 in it, that has a 4. I'm going to divide the top and bottom by 4. Okay, so I get 206 times 4 over 360 divided by 4. I get 90. And then I'm like, okay, I can probably keep going, right? These are both even, right? 4 and 90, or I could divide by 2. Divide by 2. We get 103 over 45. So it looks like I got down to close to what I want here, right? 45 is 3 times 3 times 5. So I almost have a prime number in the bottom. Yeah, so 103 times 4. 103 times 4 is 412 pi over 45. Now let me check that decimal. So is 412 divided by 45. Oops, something went wrong because I didn't get 54. Let me try that again. 206 divided by 360 times 16. Yeah, I did something wrong. So I did reduce it right, but I typed this in my calculator wrong. So here, when I type 206 divided by 360 times 16, I get 9.15 repeating pi, and this is the same as that decimal. Cool. Okay. Now for sectors. It says for sectors, I'm going to use this formula, right? So I have a sector, and my angle has to be 63 degrees. So if my radius is 10, the area of my circle is pi r squared. So that would be 100 pi is my area. So I want the fraction 63 over 360 times my area. So 63 over 360 times my area, 100 pi. It says leave it in terms of pi. Okay, so 10 divided by 10. These both look like they have a 3 in it, so I could divide the top and the bottom by 3. 63. Divide by 3 is 21. And I still have a 10, so that could add a 0 there, right? 360 or 36 divide by 3 is 12. So I still have even numbers, right? I can divide by 2 on the top and the bottom, and we get 105 pi over 6. Okay, that's my final answer. If I turn this into a decimal, 105 divided by 6, I get 17.5 pi. Let's start back here. Did I get 17.5 pi when I started? So 63 times 100 divide by 360. Did I get 17.5 pi? Let's figure that out. 63 times 100 divide by 360. Yeah, I get 17.5. So this is my answer reduced. This is my answer as a decimal. Okay, question number 9. What is this sector? So what is the area of this shaded in? So again, in sectors, they're asking for what's the area of that. That's why I'm using area. So I get the radius is 7, so my area is 49 pi. Right? So I want the fraction 172 over 360 times 49 pi. That's my answer. I can turn it into a decimal. 170 divided by 360 times 49. I get 23.41 repeating pi. Although they probably want me to reduce the fraction instead of turning it into a decimal. All right, so 47 is 7 times 7. But it looks like I could take a 2 out of the top and bottom right here. Take out a 2. So I can rewrite this fraction, 172 divided by 2, which is 86. And my denominator is, if I cut 360 in half, I get 180. So it looks like I can keep going because they're still even, right? At the very least, they're still even, so I can keep dividing by 2. So now we get 90 over 43 times 49 pi. I think I'm pretty much done there. Because 43, I believe, is prime. And 49 is just 7 times 7. Okay, so I think I'm done. 43 times 49 is 2107 over 90 pi. What is 21 over 7 divided by 90? It's this same number. So this number and this number are equivalent. Either one would be okay as an answer. Reason, if you know the circumference of a circle and the area of a sector, how could you determine the central angle? So you could use algebra, right? If I know that this area is a specific number, the area of my sector is equal to my central angle over 360 times my area. So if I know my area, how could I do that? How could I solve for that? So again, you can make x what you don't know. If you don't know the central angle, you could solve for this and say, I'm going to write over here to the left, the area of this sector, if I know that, would be x over 360 times the area of my whole circle, and I would just get x by itself on one side. I could also find my sector or arc, or my arc length using the same formula. So my arc length, usually we call that S, is equal to x over 360 times my circumference. I could use algebra to solve for x. Cool. All right. Let's keep going. The next class we did tangent lines. So let's take a look at a tangent line here. They give us some examples. Now let's use our notes in that example to answer this question. So this would be 13, right? If they're told this is a tangent, so that means we can add that 90. Then you also know this is 7, right? Because this is a radii, and all radii are equal. So we have a right triangle, and it says we want to solve for QR. So I'm going to make that x. So we get, this is A, and this is B, and this is C. So we're going to put 7 squared plus x squared has to equal 13 squared. 49 plus x squared has to equal 169. So when I subtract 49 on both sides, we get x squared is equal to 169 minus 49, we get 120. So we can take the square root of both sides. X is 10.95. All right. And that number makes sense. Right? It's a number between 7 and 13. Looking at question number 12, if they tell us this is a tangent, we know that's 90. What would be this angle? Well, that would be 180. Take away the 90-degree angle. So we know this has 90 degrees left, and then take away the 58. We get 32. And we can add those up just to make sure, right? Question 13, construction argument. If GH is a diameter, all right, GH is a diameter of T, is it possible to draw tangents to G and H from the same point externally? So can you draw a tangent line to G and a tangent line to H from the same point? No. We said in our definitions, right, the point, a tangent and the circle meet in only one point. Here's the point where G would meet its tangent, and that's the point where H would meet the tangent, and those are not the same point. Nice. Okay, number 14 says the segment MN is tangent. Okay, so we can, is tangent. What is the radius? So that's our radius right there, right? They're already calling it X. So if they're already calling it X, I don't have to use another letter. I'll just use X. So this would also have to be X. Okay, so the short side we call A, and the medium side we call B, and the long side we have to call X plus 5, right? That's what we'd call C. So we have X squared plus 8 squared equals X plus 5 squared. Right? So we're going to have to FOIL. Right? First terms, inside, outside. And if I'm going too fast, it's just because I'm recording, and that means you can slow down the video. You can speed up the video. You do the video. You do you. I notice here I can subtract x squared on one side, and this is going to make the problem a little simpler, right? Okay. So now we can subtract 25. All right, so we get 39 divided by 10 is x, leaving us 3.9. Now, would this make sense? I think that looks like a good enough number as any other, right? Check out the next video for section 10.3, 10.4, and 10.5.